Hey class, third and last video for talking about the waves of this week. We are going to have pulse transmission and kind of working through the worksheet. So last video I talked about how transmission actually works and what happens in the new medium, as well as kind of what sometimes gets reflected as well. Here's just the worksheet and how we're actually going to show this again kind of mathematically, or show this through our actual work. So two media are held in the same tension. So the thin line represents low density. So here's our low density that can move at basically 4 units per second. So again, every second it's going to move like 1, 2, 3, 4. And then there is a high density medium, that's this, that only moves at 2 units per second. And again, that's because the speed is actually going to slow down in this high density. And that's because, again, the energy is harder to move in this new density. So the energy transferred has to move slower. All right. So it says be sure to draw both the transmitted, which is going to go through here, as well as just that little reflected pulse that comes back for each one. All right. So it says that basically we want to know what happens 6 seconds later in this question. Now remember, the low density moves 4 units per second. This moves 2 units per second. So the best way to do this question is see what happens when it actually, like, how long it takes to get to this first change, like this first actual medium change, okay? So how many basically units or boxes does it take to get to here? So it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, wait, 10. So it took 10 units. It took 10 units to get here, right? That's how many units it is to get to the change. So how many seconds is that? Well, again, if it moves 4 units per second, that means basically it took 2.5 seconds. So it took 2.5 seconds to get to here. So if I were to draw like 2.5 seconds later, you would see something like this, okay? You see something like this. And so that's, if the question just asked you to do like something 2.5 seconds later, you draw that. But it's asking for 6 seconds later, so let's kind of keep going. So we know that at 2.5 seconds, we get this. We need to know what happens for the next 3.5 seconds, okay? Because that's how much time is left. There is 6. We need another 3.5 seconds left. So I'm going to write that down. I always write that down. 3.5 seconds left. All right. How far is it going to move on the transmitted section? Well, it moves 2 units per second over here. So let's start off with this one. So if I go 2 units per second and then 3.5 seconds, it's going to move 7 units. Okay, so we were right here. Now we're going to go 1, 2, 3, 4, 5, 6, 7. All right. So that's where this front of the crest is going to be. Now what happens in this new medium? 2 things happen. First off, the amplitude gets smaller and the wavelength gets smaller. Okay, as well, we already know that the speed got smaller, so everything got smaller. So how am I going to draw this? Well, if it was this high before, and I had a wavelength of 4, as long as both of those get smaller, I'm fine. If you want to draw it like this, where it's like 1 now, that's fine by me. If you want to draw it kind of halfway in the middle to 2, again, as long as I see that it's smaller in both ways, in amplitude and in wavelength, I'm totally good. Okay? Usually I just cut it in half. So that's what I usually do. And so there's my half. It's only 1 high, it's got the tail not as big, and it's moving in this direction. So there's your transmitted piece, all right? Now there is also a little reflected piece that comes back, all right? So when a less dense hits a more dense, it acts as a fixed end, okay? Because this little less dense is not going to move this more dense nearly as much. So it acts as a fixed end, which means the little reflected pulse comes back and it is underneath. It does a phase shift. The crest basically turns into a trough. And that's because when you go from less again to more, this acts as a fixed end, and so it goes down the bottom. So we still have to do the 3.5 seconds left though. 3.5 seconds, 3.5 seconds. And again, it's going to move at that same speed on the low end. So 4 times 3.5 gives us 14. And so let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So basically, again, the front end of this is going to come back. All right, when it gets reflected, because some of the energy went through, we just lose our amplitude a little. So it ends up looking like this. Our wavelength stays the same, but we lose a little amplitude because some of the energy got transmitted. So we have a small amplitude, wavelength stay the same, it's moving this direction. So that's how to do this question here. I'll do one more example for a video. I guess so. This is not my last video. I'll do one more example, basically going from the more dense to less dense as well. All right. Perfect. Thanks. All right. Got a race over here. Switch. All right. Thanks, class.